In this video, we provide a brief introduction to wired and wireless networks and talk about their performance. Now, there are many different modes of connection, and these fall into two broad categories, wired and wireless. In terms of wired, you need to know about fibre optic and copper cables and the protocol Ethernet. For wireless, you need to know about wireless, Bluetooth, RFID and NFC, and ZigBee, and we'll go through these now. Connections between desktop computers and a switch or router are usually achieved with a wired connection. This ensures maximum bandwidth, security, and reliability. The wired connections are made of twisted pairs of wires which are twisted around each other to reduce interference. There is normally a set of wires for transmission and a set of wires for receiving data. Different grades of copper and insulation material can affect the quality of the cable and therefore the bandwidth. These copper cables are referred to as twisted pair, unshielded twisted pair UTP, Cat5, Cat6 or Ethernet cables. Another type of copper cable known as coaxial cable can also be used, but it's less popular in computer networking today. This is the cable used to connect a TV to a Freeview box and an aerial. Fibre optic cables use light to transmit data. They can cover much longer distances than copper cables and have a higher bandwidth due to reduced interference. They are therefore used in high traffic connections such as between switches and to remote buildings. The backbone of the internet is made of fibre optic cables. So here's an example of a modern star network. With twisted pair cables, duplex communication is possible, in other words sending and receiving data at the same time. As opposed to a type of cable, Ethernet is actually a protocol that's commonly used for data transmission via a wired network. Wi-Fi is a common standard for wireless networks. The main advantages of Wi-Fi networks over a wired one is that users can move around freely within the area of the network with their laptops, handheld devices and phones to get an internet connection. Users are also able to share files and other resources with other devices that are connected without having to be cabled into a port. Not having to lay lots of cables and put them through walls can be considerably advantageous in terms of time and expense. It also makes it easier to add extra devices to the network as no new cabling is needed. If you're a business, say a cafe, having a wireless network that's accessible to customers can bring you extra business. Customers generally love wireless networks because they're convenient. Wireless networks can also sometimes handle larger amounts of users because they're not limited by a specific number of connection ports. Instant transfer of information to social media is made much easier. For instance, taking a photograph and uploading it to a common social networking site can generally be done much quicker with wireless technology. Like most things in computer science, there are always trade-offs, and what you'll find with wireless networks are the speeds tend to be slower than wired networks. It has to rely heavily on signal strength to the wireless access point. Signals can become too obstructed. It's also considered much less secure than a typical wired network. Bluetooth is another, more modern and increasingly popular method of connecting devices wirelessly. It has a very short range compared to Wi-Fi, but it also consumes a lot less power. This makes it ideal for connecting personal devices as shown here. So near-field communication, or NFC, is a method of wireless data transfer that detects and enables technology in very close proximity, so typically less than 10 centimeters, to communicate without the need for an internet connection. It evolved from the radio frequency identification technology, RFID. An NFC chip operates as one part of a wireless link. Once it's activated by another chip, small amounts of data between the two devices can be transferred. No pairing code is necessary to link up, and because it uses chips that run on very small amounts of energy, NFC is much more power efficient than most other wireless communication types. Almost all mobile phones and many payment cards and security ID badges now make use of NFC and RFID communication technology. The final one for wireless you need to know about is ZigBee, and this is an international standard for wireless communication created by the ZigBee Alliance. It's used for two-way communication between sensors and control systems. It's a short-range communication standard similar to Bluetooth and Wi-Fi, and its range is around 10 to 100 meters. The main difference is it only supports the transfer of very simple data, for example between sensors. Data transfer rates max out at around 250 kilobits per second. It's ideal for applications that require low power, low cost, low data usage, and therefore a long battery life. So on the screen is a quick comparison of the 4 wireless technologies you need to know about for the exam, along with their rough range, bandwidth and power consumption. Pause the video and take some notes. Now for your exam, it's important to understand how the different characteristics of a wired and wireless network impact on performance. And in particular, when we talk about performance, there are 4 words you need to be aware of: speed, range, latency and bandwidth. Let's have a look at each of those in a little more detail. So speed is the transfer rate of data from source to destination, measured in bits per second. For example, 50 megabits per second. And we look at network speeds in the next video in more detail. Range is the maximum distance a transmission can travel before becoming degraded or corrupt. Wireless typically has a much shorter range than wired networks. Bluetooth typically has a shorter range than Wi-Fi, whereas with wired networks, copper cable has a shorter range than fibre optic cable. Latency is the amount of delay or the time it takes for a transmission being sent to it being received. Again, latency tends to be worse for wireless networks over wired networks, and it's certainly worse for copper cables over fibre optic cables in a wired situation. Bandwidth is the maximum amount of data that can possibly be transferred per second, and you can think of this as the size of a pipe with water flowing through it. You should not confuse this with network speed, which is the actual transfer rate of data. A combination of network speed and bandwidth gives us what is known as throughput. So let's just summarise some of the advantages of wired versus wireless networks. With wired networks, transfer speeds tend to be faster, they tend to be more secure, and the connection speeds tend to be more reliable. However, the user's location is obviously limited by a physical cable. Lots of cables and therefore lots of connections and ports means extra physical hardware is needed, and it's generally less convenient to share files as we need access to that physical connection. With a wired network, users can access networks from anywhere within range. It's far less complicated physically and less disruptive physically to set up. It tends to be easier to share files as this physical connection to a cable is not required. But on the downside, transfer speeds do tend to be slow on this type of network. It can be seen as less secure, or indeed more steps need to be added to make a wireless network secure. And the connections tend to be less reliable. They can easily be blocked by walls and other physical infrastructure. So just to summarise, wired networks tend to be more reliable, secure and can transfer data at faster speeds. They however require additional cabling, which can be difficult to install and impractical. Wireless networks are more flexible as there's no need for this physical connection, but they tend to be less reliable and secure and typically have lower transfer speeds than their wired equivalents. Make sure you're aware of the 4 terms you need to understand for the performance of network speeds. That's speed, range, latency and bandwidth, and the difference between them. The rest of this video goes a little beyond the GCSE specification, so there's no need to take any more notes. It's well worth watching, however, as it helps to add an extra level of understanding behind how Ethernet and Wi-Fi actually work, and it's excellent preparation for A-level. So in terms of Ethernet that we spoke about earlier, let's have a look at what happens to data being transmitted from computer A to computer B on a wired partial mesh local area network. The first thing that's going to happen is the data is going to have its header and CRC applied. Now, for the purpose of this illustration, the header includes the preamble, the start frame delimiter, the source and the destination MAC address. Before the computer goes ahead and transmits this frame, it's going to check whether there's another communication on the cable that's attached to. Now, if we're using twisted pair, this isn't strictly necessary, but we're going to go ahead and do this anyway. So seeing that there's no communication on the line, the frame is then transmitted to the switch. The first thing that happens here is we examine the CRC and check that the frame arrived intact, and if not, we'd have to request for it to be retransmitted. Let's assume that the CRC check is successful. The switch is then going to examine the destination address in the header and make a decision about which port it should send the frame down. Before transmitting, the switch is going to check there's no communication on the cable, and then it's going to send the frame down. And seeing that there isn't, it can transmit the frame to the next switch. The switch is going to have a look at the CRC, check that it's been transmitted correctly, and then examine the destination MAC address in the frame. Realising that it's for computer B, it can then send the frame down the cable, of course checking there's no transmission on the line already. The frame is then sent to computer B, where it can be unpackaged. After the CRC check has been performed, the header and the CRC is stripped away, and the computer is left with the data. You'll notice that this network is significantly more secure because the data only travelled between the switches that it needed to, and the other computers on the network were completely unaware of the transmission. This is how the Ethernet protocol works. Now let's take a look at how wireless works in a little more detail. Because wireless is using electromagnetic radiation to transfer signals between 2 points, they have to be transferred on a number of frequencies, and each frequency is given a channel number for convenience. So for example, BBC Radio 1 is at 97 MHz, BBC Radio 2 is 88 MHz. We can think of radio channels as being on a frequency and at the same time being on a channel. The same is true for Wi-Fi networks. Different countries can operate different frequency bands, and here we have a typical illustration where we've got 2.437 GHz being channel 6 on a Wi-Fi network. This means that if your network interface card on your computer is set to channel 6, and your router is also set to channel 6, then the two devices can communicate with each other on channel 6, and indeed with any other devices that are on your local area network, as long as they're also tuned to channel 6. It's completely up to you which channels you decide to use, but there are some implications for interference with adjacent channels. Each channel is actually 22 MHz, which means for channel 6 you get some bleed over to channel 5 and to channel 7, as we can see shown here. This is generally not considered a problem because you've got filters that will filter the frequency that the device is actually listening to. However, it would be a good idea to make sure that you're using a different channel to another local wireless network. So for example here, we might decide to use channel 3 if our neighbour is using channel 6. Here we can see the full range of channels and frequencies used by Wi-Fi. Now this is really too much detail for the exams, as we've said already. All you need to know is that Wi-Fi is operating on frequencies and frequencies can belong to channels. As long as two devices are transmitting and receiving on the same frequency or channel, then they can exchange data with one another.